Hey, how's everyone doing today? So today we are going to be working on something called the most common ion. The most common ion is going to be known as this thing called the MCI. The abbreviation is MCI, the most common ion. But before we do that, we're going to review some of the things that we've been doing before because it's really going to help us out in our understanding. I suggest that you have a periodic table. I suggest that you have um, some notes so that you can take some notes while we're doing this lecture. Now, just a reminder, this is our periodic table that I've just kind of created for us, where I've made the first column red, or the first row, and then the second row is blue, third is green, fourth is pink, and we're leaving out this black section right now because it's not coming into play. These rows directly correlate to the shells, and then the columns, the 1, 2, 3, 4, 5, 6, 7, 8 that you see, those are the valence electrons. And remember that valence electrons, those are the outside electrons of an atom. But what we're going to do right now, we're going to start off by, we're going to draw the Lewis structure of a neutral magnesium. All right. Now, it's very straightforward to do, but what we want to do is draw the shells first. So we're going to draw the shell model. I'm going to do this as a review for you. So let's take a quick look. Here we go. Whoops. All right, so we're going to have magnesium. So here's our magnesium. And it's neutral magnesium. And remember, when something's neutral, the number of protons equals the number of electrons. Why? Because there's no charge on this atom overall. The protons cancel the electrons out. So the magnesium that we're going to be working with is right here. So this magnesium has 12 protons and 12 electrons. And so what we want to do is look and say, well, how many shells does this have? Well, it looks like we have 3 shells. We have our red shell. I know you guys asked before. Nope, these are not the real colors of an actual atom, okay? These are just my own way of trying to show you the patterns of the atoms. We don't have a red, a blue, and a green. Another teacher might have chosen different colors to use. I just wanted it to correlate to what I have. So back to it. So we have, this would be our shell model. So magnesium's on the third row. And we want to say, well, how many protons and electrons do we have? Well, it looks like we have 12 protons and 12 electrons because that's how the neutral atom works. Equal numbers of protons and electrons. So how many do we have? Let's count. We have 1, 2. Remember that each box represents 1 electron. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The last electron is in row number 3, or shell number 3. The first shell has how many electrons? It has 2. The second shell, all of them are there. That's a maximum number. We can't put any more than 8 in any shell. This one has 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's the 8. And then we have 1, 2 in our last shell, our third shell. This would be the Lewis structure of magnesium. Now, if we're going to draw from this, we're going to go draw our Lewis structure. Remember, the Lewis structure, those are the Lewis structure, that's the symbol for just the electrons on the outside. Okay, just those valence electrons. How many valence electrons do we have? Let me highlight these in yellow for you. So you can see here, we're highlighting these in yellow. That's the valence shell because it's the outside shell, and we have 1, 2 electrons in the valence shell. So we're going to put 1, 2 electrons in our valence shell. And that is our Lewis structure. Now, let's take a quick look. We have how many valence electrons? Well, we have how many, so it has how many valence electrons? We have 2 valence electrons, right? And then it says, how many shells do we have? There's 1, 2, 3 shells, right? Because that's what the question's asked. And that's it. And then obviously there's 12 protons and 12 electrons, which we had to know. Now, what we want to do now, let's take a look at this one here, which is Mg2+. So let's take a look off to the side. So let me move this out of the way a little bit. So we have Mg2+. Mg2+, we're going to write Mg2+. All right. We want to know, and here's where Mg is. So let me erase all this other stuff. So now let's take a quick look at Mg2 plus. I'm just going to draw. So how many protons does Mg2 plus have? Well, here's our magnesium. Magnesium is going to have 12 protons. But you notice there's a charge right here? Since there's a charge, notice it's positive. Well, we always are going to have 12 protons. We can never change that. So 2 plus means there's 2 extra protons. So how many electrons would we need in order to have a 2 plus charge? We can do that by saying the charge equals the number of protons minus the number of electrons. We know the charge is a 2 plus. We know that we have 12 protons minus what is going to give us 2. So 12 minus what equals 2? You should be able to do this in your head. That should equal 10. So that means you have 10 electrons. So we have 10 electrons in Mg2 plus. It's very important that you understand that idea. So let's quickly fill in those 10 electrons. Here we are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like our last electron is on our second row. So what we want to do now, let's draw our shells. So we have shell number 1, and then we have shell number 2. And as we're sitting here, we're going, okay, well, I don't think we need that third shell because we don't have the electrons for it. So how many electrons are on our first shell? 1, 2. And our second shell is full. So the second shell is stable. So we have 1, 2, 3, 4, 5, 6, 7, 8. There it is. And this pretty much wraps up our shell model. So now let's take a look at our Lewis structure. Now, what's the difference you see between magnesium and magnesium 2 plus? The biggest difference you can see is that the valence electrons that were on the outside of magnesium, these 2 electrons were lost. So those 2 electrons were lost, thus making a solid shell on the inside, which is going to give us 8 electrons on the outside in the valence. 1, 2, 3, 4, 5, 6, 7, 8. All right, so this would be our Lewis structure. How many shells do we have? Well, we have 2 shells. Let me shrink that down a little bit for us. We have 2 shells. How many valence electrons? 8 valence electrons. As opposed to this one that had 2 valence electrons and 3 shells. So in losing these 2 electrons right here, we've gone down to that other shell. All right, so we're going to use this information today to help us with our MCIs. And we're going to start that right now. So now remember that the whole point of our lecture today was going to be about something called MCIs. Those MCIs are called most common ions. Now the idea behind this is to say each atom will lose or gain electrons. So are things going to gain or lose electrons? Well, the idea is that atoms do not like having an incomplete shell. What does that mean? Well, atoms want to make sure that they have 8 electrons. Remember we had these 8 electrons going across? So if an atom is right here, and we don't have a complete shell, the atoms are not very happy. But if there is a complete shell, the atoms are, I say happy, but they're more stable because it's all about stability, okay? So let's take a look. Whoops, let's go back. There we go. So what we want to do, let's take a look. So atoms don't want to have incomplete shells. Atoms are going to try and empty up or fill their outermost shell. So we just did that with magnesium, and you might not have even realized it. But here we have magnesium. So there's magnesium. We had our first shell. Okay, so I just jumped with you so you don't have to waste time me drawing. So magnesium, this is what magnesium looks like. It's got 2 on the inner shell, then 2 in this outside shell, and then it's got 8 in the middle shell too, and then 2 in the outside shell. So is magnesium stable? You know, magnesium, believe it or not, is not very stable. It's very reactive. And it's reactive because magnesium would prefer to have a full shell, right? So magnesium could either gain electrons or lose electrons. So here's the question. Do you think magnesium wants to gain 1, 2, 3, 4, 5, 6 electrons? You have to gain 6 electrons, or you think it's easier for magnesium to just lose those 2 electrons? Well, it's going to be easier for magnesium to lose these 2 electrons right here, right? Magnesium is going to lose these 2 electrons. And in doing so, magnesium is going to become magnesium ion, right? It's going to become magnesium ion of most common ion. So, and that's what a most common ion is. It's an atom's ability to gain or lose electrons so that it's more stable. And we've done this several times. You guys just didn't realize it. So let's do some examples and practice. So let's take a look at how we're going to draw some of our most common ions. How are we going to determine our most common ion? How will we know that magnesium is a +2, that oxygen's a -2, that lithium's a +1, right? We're going to take a look at that right now. But before we do, let's fill this in right here. So let's take a look at this table. So let's fill this out. What's the symbol for sodium? Well, here's sodium right here. So the symbol for sodium is going to be Na. How many protons does sodium have? Sodium has 11 protons. How many electrons does sodium have? Well, remember, the number of protons and electrons in an atom that's neutral is the same. The protons equal, right, the electrons. Those cancel out. How many shells does sodium have? 1, 2, 3 shells. I'll put that one in green for you. So you can be like, oh yeah, it is on the 3rd shell. How many valence electrons do we have? I'll put that one in gray because this is kind of a gray color. Sodium has 1 valence electron. There's 1 electron on the outside edge. And then let's draw the Lewis structure for sodium. The Lewis structure is drawing the number of electrons that are on the outside. So we would draw Na, and I'll go back to my trusty purple because that's just become my electron color. That, ladies and gentlemen, would be our that would become our Lewis structure. Okay. Now, what we want to do now is take a look at how do we draw the sodium's MCI, most common ion. Now, to do that, we're going to want to draw the neutral atom for sodium. So let's draw the model of the neutral atom. So let's draw sodium. So it's going to look like this, the shell model. That's the one with the circles. So we're going to have, whoopsies, oops, sorry about that, kids. So we're going to have Na, and then the first shell is going to be red. The second shell is going to be blue. And the third shell is going to be green. And we're going to draw this for us. Now, let's fill in the electrons as well. So now that I drew in this electron shell for you, you can see that there's 1 electron in the outer shell. Now remember our purpose. Our purpose, ladies and gentlemen, is to find out what is the most common ion for this atom. Well, the question is, remember, in the outer shell, we want to have 8 electrons. So we can either gain or lose electrons, right? Gain electrons or lose electrons. So sodium has a choice right now. Sodium could, ladies and gentlemen, add 1, 2, 3, 4, 5, 6, 7 electrons. So atom sodium could gain 7 electrons and become Na7 minus, or sodium could lose 1 electron, right? Sodium could lose 1 electron, and in losing that 1 electron, could have that shell right underneath it. And what do you think that sodium's going to do? Do you think sodium wants to gain 7 electrons or lose 1 electron? Well, sodium is going to lose 1 electron. This is what sodium's going to want to do. Right here, sodium's going to want to lose this 1 electron, which is much easier than gaining 7. And that's going to mean that sodium becomes sodium ion, Na plus, right? Because we can't leave it as Na anymore. It has to be Na plus because we've lost that electron. If we put that electron back, it would be Na regular again. So you can see there's 2 electrons on the first shell, 2 electrons on the first shell, right? On the first shell, and 8 electrons on the second shell. The key there is these 8 electrons are going to make sodium ion very stable. Okay, so let's take a look. What would be the number of protons that sodium has? Sodium ion has. It's MCI. It's going to have 11 protons. We can see now 8, 9, 10. It's going to have 10. No longer are we on the third level. Now we're on the second shell. How many valence electrons do we have? Well, now valence is the outside, so we have 8 valence electrons. The symbol now is going to become Na with a plus charge. And what would our Lewis structure be? Our Lewis structure would be the symbol with the number of electrons around it, which would be 1, 1, whoops, 1, 2, 3, 4, 5, 6, 7, 8. And so all of this information, sorry, I had to stop that video for a second. But so all the information we have was right here of how to draw it. So you draw the neutral atom, and then you figure out, is it easier to fill it up and get to 8, or is it easier to lose to get to a full shell of 8? Because remember, 8's the maximum we can use. And then you calculate the charge. If you take away 3 electrons, it's going to be a plus 3. If you add 3 electrons, it'll be a plus 3. So yeah, all right, let me get the next page set up for you. Okay, so here we are. This is going to be a handout that you're going to see very similar to this. And so we're going to take a look and see if we can figure out what is the most common ion, or we're basically looking for the charge. That's what that is. What's the most common charge that nitrogen's going to have? Because an ion is a charged particle. So the first thing we want to do is we want to find nitrogen. And you can see nitrogen is right here. Nitrogen is in the second shell, all right? Nitrogen has 7 protons. Nitrogen has 7 electrons. But we want to know, what will nitrogen become if it becomes an ion? So it has 5 valence electrons, which means its outer shell has 5. Now we know that the maximum number of electrons that we can have in an outer shell would be 8. And nitrogen has 5. So let's go through this process right now. So we're going to draw nitrogen. That's a little big. Sorry about that, kids. We're going to draw nitrogen. We're going to draw nitrogen. And now we want to say, does nitrogen, how many valence electrons does nitrogen have? Nitrogen has 5 valence electrons. So it's going to have 5 electrons in its outer shell. Now, what's the maximum number of electrons that nitrogen can have in its outer shell? Well, nitrogen can have 8 electrons maximum. All of them can have 8. 8's the magic number. So are we going to want, or is nitrogen going to want to gain an electron to get up to 8, gain electrons, or will nitrogen want to lose electrons? So right now, nitrogen has 5 valence electrons. The magic number to try and get to is 8 electrons, right? Because it wants to fill this whole shell, because if there's 8 electrons, the atom is more stable. Well, if nitrogen is going to gain, how many electrons would it need to gain? It would need to gain 3 electrons. If nitrogen was going to lose electrons so that it would come down and have a full shell right here, right? It would have 2 electrons as a full shell. It would have to lose 5. Now, what do you think would be easier? Gaining 3 or losing 5 electrons? Which one do you think is easier? Gaining 3 or losing 5, right? Gaining 3 or losing 5. I personally, well, it's going to be easier to gain 3 electrons. So nitrogen is going to, let me choose another color here that's kind of close, but so that you can see a difference, I'll choose that color here. Nitrogen is going to gain 1, 2, 3 electrons. And in gaining those 3 electrons, nitrogen's going to have how many valence electrons? Well, nitrogen now is going to have 8 valence electrons. 8 valence electrons. And those 8 valence electrons are going to be added to this. So how many total electrons? Total electrons, I'm writing so big, let me drink that. Total electrons is going to be 10 electrons. Because, well, yeah, because we have these 2, we had 7, now we added 3 more. Now, what would the charge be? Well, we started off with 7 protons, right? Because nitrogen has 7 protons, but now nitrogen has 10 electrons because nitrogen has gained 1, 2, 3 more electrons. So nitrogen now would have a charge of 3 minus. So let's write this thing in. Let's take a look. So what would be the MCI for nitrogen? Well, nitrogen would have a charge of 3 minus. Its total electrons are going to be 10 total electrons. The number of valence electrons are going to be 8 because 8 is a very stable configuration. Are we gaining or losing electrons? Well, in this case, we're going to gain 3 electrons. All right. How many shells? Well, there's going to be the 2 shells. And then with the Lewis structure, this would be the Lewis structure right here. It would be nitrogen with a 3 minus. And then we're going to put in our electrons. 1, 2, 3, 4, 5, 6, 7, 8. That would be our Lewis structure for nitrogen. So we have a charge of 3 minus because we gained 3 negatively charged particles. So if we gain 3 negatives, we're going to become more negative. All right, ladies and gentlemen, so let's keep on going here. So what we have now, let's take a look at neon. Now, remember that we said that each one of these valence electrons goes all the way down. So calcium has 2, magnesium has 2, carbon has 4, germanium has 4, sulfur has 6 valence electrons. So each one of these columns, they all have the same number. That's going to make it a little bit easier. Now, something that we're going to do now, let's take a look at neon. Now, neon is the same as all the other ones in this column right here. But neon is kind of a special case, all right? So what's the special case? Well, here's neon. Let's take a look. Let's draw neon. Let's draw its Lewis dot structure, okay? So we know neon, let me make that a little bigger for you. Neon has 8 valence electrons. There it is. Neon has 8 valence electrons. But we want to say, well, what's the MCI? What's the most common ion for neon? Well, here's the question. Neon has, ladies and gentlemen, 1, 2, 3, 4, 5, 6, 7, 8. Neon already has 8 valence electrons, which means that neon already has a full shell. So the question is, does neon want to gain, do you think, or lose electrons? Does it want to gain electrons or lose electrons? Well, neon already has 8, and believe it or not, neon doesn't want to gain any. Neon doesn't want to lose any. Now remember, all of these atoms right here, they all have the same number of valence electrons, which means they're all going to act the same as neon. All of these in this last column will have 8 and will not want to gain another one. Okay, so let's continue. Oops. So let's draw this in for neon. So what's the MCI? There is no MCI. There's no common ion because neon does not become a common ion. How many total electrons? Well, if we look at neon, it has that 10th electron. Just for those of you that might be like, where are the other ones? Yes, oops, these other ones are in there as well. Those other electrons are there, okay? So how many total electrons? 10. You can see it, 10 total electrons. How many valence electrons? Well, we can see it right here. There's 8 valence electrons. We also know that because it says 8 up here, and that 8 is the number of valence electrons. The only exception would be helium here, but so there's 8 valence electrons. How many were gained or lost? None. How many shells? 1, 2 shells. And what would the Lewis structure be? This would be the Lewis structure. Lewis structure right here. Now on the last one that we did, there were 1, 2, 3, 4, 5, 6, 7, 8. So neon would have this. Just a quick review. Why does this one have 3 different colored electrons? I did that so that you would see, oh, look, we added 3 electrons to get to 8. All right, these I left as all the same color. Now let's do another example of one, and this one is a little bit different as well. So I'm doing 3 kind of exceptions for you. All right, so here we go. Let's take a look at the first one. Carbon. What's the MCI for carbon? Well, first, let's draw carbon, and its Lewis dot structure. So let's just take a quick look here, okay? And we will take a look. I just came in. I just deleted the screen so we could start over. So let's take a look at carbon. It's our next example. It's kind of odd. So let's take a look at carbon. Whoops. So the first thing we want to do is we want to, let's take a look at things. So what is the number of shells that carbon has? Carbon has 2 shells. Okay, carbon has 2 shells. You can see it right here, 2 shells. How many protons? Carbon has 6 protons. This is carbon right here, 6 protons. How many electrons does carbon have? Carbon has 6 electrons because 6 protons and 6 electrons, we said that many times. There are how many valence electrons? This is the valence electrons. Carbon has 4 valence electrons. And you would know that because 2 of these 6 electrons have to be on the inner shell, right? And so let's take a look. So we have 4 valence electrons. So let's put that in. So we have 1, 2, 3, 4. Now the whole key to figuring out the MCI, or the most common ion, what charge is it going to have, is we want to look and we want to say, is that carbon going to gain electrons or lose electrons? And the carbon is going to do whatever is easiest. Now remember, we've said this before, these atoms want to have 8 electrons in the outer core. One more time, 8. 1, 2, 3, 4, 5, 6, 7, 8. Maybe it's the 3rd row. There's 8. 4th row. There's 8. 5th row. There's 8. They always want to have 8 electrons in their outer row. So if Carbon wants to have a solid outer row. It has to either gain 4 electrons, because right now it's sitting right here. There's 1, 2, 3, 4, 5, 6. So it would have to gain 1, 2, 3, 4 electrons, right? Or carbon would have to lose 4 electrons. So what's carbon going to do? Well, carbon is one of these weird examples where it's not going to gain and it's not going to lose any electrons. Carbon doesn't have a most common ion. So if you ever see something that has an equal number of electrons possible to gain as lose, which would be silicon, germanium, and the other ones that are down here, because these are all the ones that have 4 valence electrons, there is no most common ion. Okay? It doesn't turn into an ion. So its most common ion, whoops, it has no most common ion. So it has no MCI. Okay? Should be a capital I. How many total electrons does carbon have? Carbon's total number of electrons equals 6. How many valence electrons? Carbon has 4, because it doesn't have an MCI. How many electrons are gained or lost? None. Not going to gain or lose any. How many shells? We have 2 shells. And what would the Lewis structure look like? It would look just like this one over here. 1, 2, 3, 4. Okay? So let me make this a little bigger so you can see. 1, 2, 3, 4. All right, so let's move on. Now, I don't want to take too much longer because I know videos can get long. So we're going to go through hydrogen. Remember, these 3 right here, these were going to be 3 exceptions, right? Sorry, I added another one at the bottom, which I'll go through. So what would be the MCI for hydrogen? Well, first, let's take a look. Hydrogen has how many valence electrons? How many protons? Hydrogen has 1 proton. Hydrogen has 1 electron, 1 proton, 1 electron, okay? Hydrogen has how many valence electrons, ladies and gentlemen? How many valence electrons does hydrogen have? That's right, hydrogen is going to have 1 valence electron, okay? And that's that 1 electron because it's on the outside. So hydrogen is special because remember we said when you have a row, so this is row 1, so row 1 can have a maximum, right? So row 1 can have a maximum of 2 electrons. So hydrogen has that 1 electron out there. And is it going to want to gain or lose its electron? Well, hydrogen is actually, in this case, you would think, oh, maybe you gain or maybe lose. Hydrogen is always going to lose 1 electron, okay? It's not going to gain an electron to have 2. So you just have to memorize that hydrogen is always going to lose an electron. And if we lose that electron, then it's going to be sitting as H+. So you're just going to have to learn that hydrogen is always going to be an H+ ion. Okay, so hydrogen, so the MCI is going to be H+. The total electrons is actually going to be 0 because there are no electrons. The valence electrons, there are no valence electrons. What's going to happen? It's going to lose 1 electron. It's only electron it's going to lose. And there are no shells. Why are there no shells? There are no shells because there's no electrons. So hydrogen doesn't have any shells because there's no electrons. And lastly, what would the Lewis structure look like? The Lewis structure would just look like that because there are no electrons going around it. So let's take a look at calcium. Calcium is right here. It's element number 20. So I'm going to go through this one very quickly with you just so we can have another example. I did nitrogen, which is a minus. I did magnesium earlier, but we're going to do calcium just so we can have experience with one more. So I'm going to start talking faster to speed the video up. So let's just take a look. Calcium, ladies and gentlemen, has, oh my gosh, that didn't help. Calcium, ladies and gentlemen, right, has how many protons? 20 protons. Calcium has 20 electrons. Calcium has 2 valence electrons. So calcium has 2 valence electrons, right? And let's use that. So let's start there. So here's 1. So the valence electrons will be used for the Lewis dot structure. So we have 2 electrons on calcium. Is calcium going to be a happy camper? No. Why isn't calcium happy? Because calcium, just like all the other elements, wants to have 8 valence electrons going around it. Well, how would calcium have it? Calcium's right here. What would calcium have to do? Does calcium want to, and we'll do our different examples, is calcium going to want to gain, so we'll just say that this is where we started, is calcium going to want to gain 1, 2, 3, 4, 5, 6 electrons, or is calcium going to want to lose those 2 electrons? Now, remember, we have our first shell, and then we have our second shell, which is going to be full. And in this case, then we would have our third shell, which is full. And then we have our fourth shell on calcium, right? So calcium is sitting out here with these 2 electrons, and then it has 8 electrons in here, and then 8 electrons, and then 2 electrons at the very end. What is calcium going to do to become more stable or to get 8? Are we going to gain 6 electrons, or are we going to lose 2? What would be easiest? The easiest thing to do is to lose 2 electrons. And when calcium loses these 2 electrons, it becomes less negative. It loses those 2 electrons, which means now calcium is not going to have 20 electrons. Calcium loses those 2. Calcium now has 18 electrons. So what's it going to be? Calcium's MCI is going to be a calcium with a 2+ charge. Total number of electrons, it's not going to be 20. It's going to be 18 because it lost 2 electrons, right? Valence electrons, how many? You'd think 2, but no. We're going to redraw because we're talking about now calcium 2+. So how many valence electrons? 8 valence electrons. What did we do? We lose 2. How many shells? Well, now we're coming back and we're going to come down to 3 shells because remember, this has 18 electrons, right? And so it's going to be sitting at 1, 2, those are kind of big, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are the 18 electrons. So that 18th electron is going to be sitting on the 3rd shell. So this one is going to be 3 shells. And then what would be the Lewis structure? The Lewis structure would be Ca2+ with all of these electrons sitting in there, 8 electrons. Now, all of these atoms want to have 8 electrons in their shells because they're more stable, whether they're gaining to get to 8 or whether they're losing and then falling back on this center shell. So here, these are the exceptions. So make sure you keep that in mind. And I want to show you this, which is every one of these have the same number of valence electrons. So these are all related. So nitrogen has 5, like we said. If nitrogen's going to have a 3- charge, then phosphorus, which is right here, is going to have a 3- charge as well because it needs 3 more electrons. So this periodic table is going to teach you how to cheat, and it's going to teach you how to find tricks. So I'm sitting here during class. If you need me, please let me know. Apologies that the video went a little long, and we're out. So have a very good day, ladies and gentlemen.